right, guys, welcome back to episode 3 of this Microeconomics Critic. Right here, we're going to be talking about quantity theory of money and Fisher equation, and these two are related. Irving Fisher kind of helped develop the quantity theory of money, or added onto it to help us expect inflation. And so quantity theory of money is only applicable in the long run and not the short run. So remember that's the first key step. And to measure the quantity theory of money, we can measure multiple different things. But we have to take into account 4 variables: the percent change in money supply, percent change in velocity of money, percent change in price, and the percent change in the real GDP. And Fisher's addition to this theory is that the velocity of money is constant. It doesn't change much. So we can help us to expect inflation, and we can we'll go into an example of that in the future in the long run. And this equation here is from Fisher as well. This is an important one we'll derive a little later. But I came up with a quote here that I thought was applicable. It says, if you give a man a fish, you'll feed him for a day. If you teach a man to fish, you'll feed him for a lifetime. And this is the part I added after that proverb. It says, if you teach a man the Fisher equation, he'll expect inflation of 1 fish to 2 fish. So that's pretty much the main thing. It's just help me remember that it's about expected inflation, and that we can measure that here in this equation. Okay, so we introduced previously this equation, which is the quantity theory of money equation. So change of money supply plus change of velocity of money equals the change of price level plus the percent change of GDP. And this is going to be important. We'll derive some things here. So Irving Fisher said that we can assume that the percent change of velocity of money is 0. It's going to be constant. So it's going to be like always, for example, 3%. It's going to be pretty, year to year, it'll stay the same. So that won't change much. And we can also assume that the percent change in price level is just equal to inflation. So this will just be equal to inflation, which we can represent as pi. So now we have that's equal to 0 and that's equal to pi. We can put that into a new equation. So the percent change of money supply equals the inflation plus the percent change in GDP. So now we're breaking it down. So now this is pretty much all we have in this quantity theory of money equation. Or we can get the inflation, which is equal to the percent change in money supply minus the percent change in real GDP. And we derive here from this quantity theory of money that by the quantity theory of money, inflation occurs when the percent change of money supply is larger than the percent change in real GDP. And that, my friends, is very important. And we'll go an example right now into this. But remember this equation here. We can use this in the future as well. So percentage of money supply plus percentage of velocity of money equals a percent change of price level plus the percent change of output or real GDP. We can expect this in the future by using this equation. So the pi to the e, anything to the e is just expected. So that's just a notation for expected change. So that's not known, but expected by the government or the bank, central bank, whatever. So the expected inflation rate is equal to the percent change of money supply plus the percent change, and that's changeable. The central bank can change that, plus the percent change in money velocity expected. That depends on how much people are spending money, minus the percent change in real GDP. And then we'll also plug this in. As you can see, pi equals e, and we can plug this into Fisher's equation to solve for I, which is the nominal interest rate. We love that. We want to solve for that. So that's what we want, guys. And now let's go ahead and take a look. So now we have here the money growth rate. That's the money supply is going to be 2%. And that's set by the central bank. So in this case, we'll say, for example, the central bank, the leader of the central bank is Gabby, or Professor Gaynor's dog is going to be the leader, and she's set at 2%. And the expected rate of change 1.3%, 2.1% is the growth in GDP, and 3.2% is the real interest rate. So now let's go ahead and break this down. So we can do the expected inflation rate is equal to we can look here, so the change in money supply plus the expected change in velocity that's set by the market, how many people are spending money, how quickly it's spent or moved. And then we subtract, of course, the output level or real GDP. So that's going to give us that. So that's going to be equal to, after we do the math, that's going to be equal to 1.2%. And then we can plug it into the Fisher's model, which is going to give us R plus 1.2%, since that's going to go in there. I is equal to, and we take here the real interest rate, 3.2 plus 1.2%. The nominal interest rate is going to be equal to 4.2%. And that, my friends, is it. That is the nominal interest rate. That's what we're looking for. And that's going to be important for measuring different things in investments and the future of the economy, how it's doing, and measuring a kind of a compilation of all these factors to give us a kind of a measurement of how well the environment of the community is doing. Well, anyway, thanks for watching, guys. Hope you enjoyed. Thanks for coming to Gainerville. All right, peace out.